Okay, this is actually a question of an optimal launch angle, the launch angle being theta here, to get this projectile, which is I thought a marble, yes, to get it as far as possible on this plane H. That makes an angle alpha with the x-axis. So it's a question from the entrance exam for engineers, mathematicians and physicists into Flemish universities, and you can see only 29% of them got this one right. So if you want to have a go at it, you can pause the video and read the question and try it for yourself. I'll put it a bit bigger on the screen. Okay, so the question is, the figure shows in dashed line the path of a marble shot uphill on a plane H. That makes a fixed inclination angle alpha with the horizontal plane, and the marble is shot at a variable angle theta, so this one, with the horizontal plane. In a model neglecting friction, the following relation holds between the x-coordinate of the point where the marble lands on the incline, so somewhere here, the angles alpha and theta, and the initial speed v0. So tangent alpha minus tangent theta is minus 2 over the v0 squared times cosine squared theta, all this times x, where g is the acceleration due to gravity. Let theta max be the angle at which the marble lands as far as possible from the starting point O on the inclined plane for a given angle alpha and initial speed v0. Which of the following expressions is then satisfied? And then you get tangent times tangent, either 2 alpha or theta max or 2 theta max. Various combinations being either 1 or minus 1. Obviously alpha and also 2 alpha then are constants, and we have theta max and 2 theta max in here. Okay, so we can rewrite that in function of x. You see the minus sign here, so I'll just swap those two around. So we get tangent theta minus tangent alpha, and then this goes to the other side, v0 squared times cosine squared theta divided by also to the other side 2, which gives you x. Now tangent theta minus tangent alpha, you can obviously write that as sine theta over cosine theta minus sine alpha over cosine alpha, and if you put these on the same denominator, you get cosine theta times cosine alpha as denominator, and as numerator sine theta times cosine alpha minus sine alpha times cosine theta. This one is you can write that as sine of theta minus alpha. So also still divided by cosine theta, cosine alpha, obviously. So you can rewrite x as being v0 squared times cosine theta squared over 2 times sine theta minus alpha over cosinus theta cosinus alpha. You can get rid of one cosinus theta here, and then I'll just gather everything that is constant, which is v0 squared over 2 times cosinus alpha, and then we'll be left with cosinus theta times sine theta minus alpha. Now this one, you can rewrite that again. So the sine of theta minus alpha times the cosine of theta is 1/2 of the sine of the sum, so theta minus alpha plus theta, plus the sine of the difference, so theta minus alpha minus theta, which obviously gives you a sine of 2 theta minus alpha plus sine minus alpha, and minus sine minus alpha is the same as minus the sine of alpha. Now the sine of alpha is again constant, so the only thing that changes in the whole formula we have here is the sine of 2 theta minus alpha. So if we want to maximize that, then this thing has to be max. So the sine of 2 theta minus alpha being maximum is, well, that's when it's 1, because a sine can't get any higher than 1. So that means that 2 theta minus alpha must be equal to pi over 2, or theta will be so the alpha to the other side and then divide by 2, so we get pi over 4 plus alpha over 2, and that is then theta max. Now we have 2 theta max in the solution, so we will have a look at what the tangent of 2 theta max is. So the tangent of 2 theta max is the tangent of pi over 2 plus alpha, or 90 degrees plus alpha, and the tangent of 90 degrees plus alpha is minus the cotangent of alpha, or minus 1 over the tangent of alpha. So if we do tangent alpha times tangent of 2 theta max, that's the same as tangent alpha minus times minus 1 over tangent alpha. You can get rid of tangent alpha and you're left with minus 1, and you can see this is solution D. Okay, there's another way to solve this. Starting from the formulas for the velocity, so Vx is V0 times obviously the cosine of theta, and that's all constant. Remember, there was no friction, so this thing can go on and on and on in the x direction. We have Vy is V0 times the sine of theta obviously, but here we have to subtract g times t because gravity will pull this thing down. Now we have speeds. The distance is the integral of the speed, so from 0 to t vx dt gives you v0 cosinus theta times t, because this is all constant. The same for y, so we get v0 sine theta times t, minus, we have a t here, so that becomes 1/2 of t squared. If the marble lands in the point P, then we have xp is op times cosinus theta, and yp is op times cosinus alpha, and yp is op times sinus alpha. So tangents alpha is obviously yp over xp, and yp is xp times tangent alpha. We have x and y, so we can fill that in. So yp was v0 times sinus theta times t minus 1/2 of gt squared, and that should be equal to x times tangent alpha, so v0 times cosinus theta times t times tangent alpha. So you can see we have a t here, here t squared and t, so we can get rid of a t and then rewrite that in function of 1/2 gt. So 1/2 gt goes to the other side, we'll be left with, and this one goes to the other side here. So we're left with 1/2 of gt is minus v0 cosinus theta tangent alpha plus what's left here, v0 sine theta, or t is 2 over g times v0 times minus cosinus theta times tangent alpha plus sine theta. So that's t. We know x is v0 times cosinus theta times t, so if we fill in t here, you can see we have v0, v0, this becomes v0 squared, 2 over g, and then cosinus theta times minus cosinus theta gives you minus cosinus squared theta times tangent alpha still, and then sinus theta times cosinus theta. Now sinus theta times cosinus theta is sine of 2 theta over 2, and well, this is a function in theta. These are constants, so this will be max if the derivative is 0. So the derivative f accent of theta equals to 0 gives you, well, minus cosinus squared. The derivative is plus 2 sine theta cosinus theta times tangent alpha, because this is just constant also. And the derivative of sine of 2 theta over 2 is 1/2 times 2 times the cosinus of 2 theta. Or 2 sine theta cosinus theta you can rewrite as sine of 2 theta, still times tangent alpha, plus cosinus 2 theta. Or if we isolate tangent alpha, we'll get that tangent alpha is minus the cosinus of 2 theta over the sine of 2 theta, or that's the inverse of the tangent of 2 theta, so minus 1 over tangent 2 theta, which means that tangents to alpha times tangents to theta has to be minus 1, and this is obviously theta max because that's what we were looking for. Again, this is answer D. Tangents alpha times tangents to theta max is minus 1.